Okay, here we go. We are live. Hey, welcome everybody once again, ding, to Astronomy Daily Live. So hope everybody's doing well out there. Everything's good here. Another just sort of a normal day. It was clear all day long, and I was looking at the satellite uh, maps all afternoon, and uh, don't know exactly what caused it, but these high clouds just sort of appeared, and not happy. So yeah, it was clear all day, clear and calm all day long, and now it's cloudy and calm. So, and well, let me check the chat. Let me get the chat rolling here. Arinstro, hey, nice to see you. Excellent. Yeah, this is just a fun, casual get together each and every day at same time, same place, 2 hours UTC on this YouTube channel. And what we do is we grab our consumables of choice and sit back and hang out and talk some astronomy for an hour-ish or so. It usually goes a little bit more. Um, so yeah, everything's good. Everything's good. Let's see. So Uncle Bill is lurking. So hey, nice to have you floating around. Carolina Sky Astronomy, Jim. Hey, nice to see you again. Excellent. And already mentioned our instro. So very cool. All right. Well, on the panel once again is Bobby. Hey, what's going on?
Hey, what's up, man?
All right. He's got a little bit of blue excitement there. Let's hope everything's okay with him. Yeah. All right. So yeah, we just get together each and every day, talk some astronomy. I just like to share, the passion. I've been doing astronomy my entire life, and I think it's really great. It's definitely probably the most interesting thing that I've ever done, um, and continue to do. Right, I've got this extreme interest in the universe, and specifically my particular situation, right? But in general, our specific situations, and yeah, it's just it's really interesting because it isn't, Carl Sagan. He talked about this in one of the episodes of Cosmos, where he was talking about a a completely random universe, right? Where just things happen, and they just randomly happen. Sometimes there's gravity, and sometimes there isn't, and sometimes there's charge, and sometimes there isn't. Um, Sometimes there's things look blue, sometimes things look red. The same thing. Things can change shape. Just all that, right? All that weird stuff. And then.
Yeah, sorry about that, Cosmic. I had to I forgot to pick up the dishes. So what we're talking about?
You've got to get the chores done. That's it. Absolutely. Oh, so I was just talking about how the universe is a pretty amazing thing, but it seems to behave um, with a bunch of different kinds of patterns, right? And that's the thing that we sort of lock onto, and try to understand what exactly those patterns are. And yeah, I mean, it's, I don't know if we sort of we are making things really complicated, or if they actually really are. I mean, what I've observed is that there are a lot of similarities to fractals, right? See, things on very, very large scales seem to also exist at very, very small scales, and so something relatively simple can appear to be quite complicated. But yeah, it's just I've always thoroughly enjoyed thinking about the universe, and you know uh, uh, observing things both near and far in the universe, both just right here, right, and things halfway across the known universe, right? And that's one of the things that I realized about astronomy really, really early on in my life, is that the astronomer, um, sort of the well-rounded astronomer. How about that? Not exactly the specialist, but specialist, but sort of the well-rounded astronomer does have a good understanding of all these things. So, all right, well, cool. So, cheers to that. So, as I said, yeah, after the live stream yesterday, the OBS session, which that was a good time during the live stream for sure. It's really, really, really nice to be outside under the sky, but the clouds. Well, right after the live stream, I came in. I looked at the satellite loop, and the clouds were just. I mean, you've got Arizona is a big state, right? It's a big state. It's like a big rectangle, right? Sort of a weird looking rectangle. And the little tiny portion that is where I am is where the clouds were. So I honestly think that was definitely some kind of a conspiracy, because it was obviously just directed at me, right? Because there was just this little cloud thing, just poked right up, was right on top of me for hours and hours and hours. It finally cleared up this morning, local time. I think around 3 or 4 a.m. But yeah, it's like, and then it was clear all day until about 4 o'clock here this afternoon, and then the clouds started rolling in again. So that is exactly the situation that I've got, and so here we are inside doing doing sort of a regular live stream, as opposed to an obsession live stream. So all right, cheers. There goes Bobby again. So let me look at the chat here really quick, see what's going on, if anything. Coffee, yes. Yeah, I don't know what it is about these clouds. They always, not always, but they oftentimes seem to conspire a little bit, and yeah, they definitely like to mess with me, for sure. For sure. All right. Bobby's scrambling around, trying to get situated here. He's breathing deep. He's getting all huffy. All right. Are you back?
Yeah, too much. I just had a crisis.
Crisis. All right. Well, crisis averted. Is it over?
Yeah.
Okay. Good. Excellent. There, that's actually one of the rules of this live stream, right? I don't remember exactly which rule it is, but the rule is no crisis, right? It's just not allowed here at all. So so yeah, good that you took care of that kind of thing, because if not, we would just have to just end the live stream or something. I don't know. All right. Well, excellent. I've started looking at some of the data that I took the other night with RLEO and the asteroids Eros and Pallas, and I've done a stack of Eros, which I posted over onto my Discord server. So let me I'll bring you over there. I'll just sort of show you what I've been up to here. Let's see. I'm there. I got to press that button. I've got to press that button. Share the screen. Hide that. I'm going to look. Somebody.
Push to a lot of buttons.
Yeah. That's exactly right, Uncle Bill. If there's not having to hurry around, you're not having to rush, then there just isn't such a thing as crisis. So let's see here. I'm gonna look at my weather. Oh. Okay, and Bobby's doing exactly the same thing. Bobby, you and I think alike. It's great. Let's see what we've got here. Fair, temperature of 65. All right. So you and I are about the same temperature, but look at the humidity difference. I'm bone dry, and you are just sopping wet. Yeah, except for the humidity, our Instro. Yeah, so you can do that. Anybody can use Nightbot in this way. I think you can type in like a city name or a zip code. So yeah, that's always great fun. I've got the amount of time that it's going to be until solstice. I have to fix the equinox command. I've got to change it, right? So it's for the next equinox. So the June solstice 2019 is 2 months, 27 days, 1 hour, 47 minutes, 6 seconds. There you go. Clear. It says that you're clear, Arnstro. I don't know where.
Yeah, but Jim also did it as well, and it wasn't responding.
Well, Jim.
So I'm not sure the one for. Not sure that's the one for Atoms, either for Jim or for Instro.
I gotcha. It's probably for Jim then. That's my guess. But yeah, he's just taking his time there, responding to whoever it is. Anyway, that is great fun. Let's go over and I'll show you the Eros long exposure here. So this is I think this is 300 stacked images. So this is, and I think.
All right, it wasn't for Jim, so I think Jim's gonna have to try it again because right now it's not responding for Jim.
Yeah, well, Jim just isn't special enough apparently. So, yeah, I would say just give it another try. Anyway, so this is about, I would say, probably about 180 stacked images. And dang it, I don't remember. I don't know if these were 2-second or 4-second exposures. I want to say they're 2-second exposures. So
I'm not sure if our intro is a shortwave radio listener, but if he is, I know Ray is. Ray's live now, but I'm not sure he's here yet. But our intro, are you a shortwave radio listener? And if so, did you listen to that special HARP presentation?
Susie. Very cool. Yeah, there it is. There it is. Yeah, well, Uncle Bill wins the highest humidity at 93%, and I win the lowest at 19. So he's closer to 100% though than I am to 0, right? So yeah, that's pretty crazy. It's pretty crazy there, Uncle Bill. Anyway, so here's just long exposure, and you can see that Eros was moving along here, and there are gaps, right? There's some black here, there's a big gap here, a smaller gap here, and there's a few gaps in between, right? We can actually zoom in on this. So we can really take a good hard look at this stuff. So yeah, I mean, it was definitely moving, right? Everything else is pretty much stable. Seeing down, pretty faint. That is definitely a I mean, it's a visual binary at least. One star right next to the other there. But yeah, I'm intrigued by the structure here, right? So you have to ignore all the black, right? Because that's either where I was taking my darks, right, or the tracking, was such that I was having to move the telescope or something. So I just wasn't able to grab that particular moment in time. So that's what a lot of these fainter gaps are, right? But it's kind of interesting how it's I don't know, it gets a little bit brighter here, and it's wiggling around a little bit, right? I mean, at least a couple of pixels, it's wiggling around. So not quite sure, this might be testing the limits of my stacking software, because if I'm off, by half a pixel, in terms of calculating where things should be, then I might be able to see that kind of artifact in that. So I don't know. I'll have to think about it a little bit. The stars look pretty round, there's, I would say, you know, a little bit of elongation here. This looks like a binary, right? One star here and one star here, and they're just sort of bleeding into one another. Let's see, is there anything else? I don't see anything else interesting, right? I just see stars, and that's good. We like that. So yeah, that's not too bad. It's interesting, as I said, that it's not exactly a straight line, right? It's yeah. I'm gonna have to understand this a little bit more, see why it's varying in brightness like that. Um, yeah, it's at this point I have to assume that, you know, it's something um, either intrinsic, like you know, like really bad seeing, and so I'm seeing scintillation effects. Um, these are pretty short exposures, you know, 2 seconds, so that should blur out a lot of the seeing. But you know, also if, like I just said, you know, if I'm not stacking correctly, you know, if I'm off by just a little bit, it's gonna make things look a little funny. So, uh, yeah, I'll have to do some experimenting um, and see if I can, um, you know, gain a little bit of confidence in what I'm seeing here, because this is a little, yeah. I mean, it is definitely going, you know, dark, brighter, 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 brightest, and then faint again. And I I I don't know what that is. And as I said, you know, it's wiggling around a little bit. So, you know, I'm not going to see any that kind of motion, right? So something is making this appear to move a little bit. So don't know what that is yet, but I'll figure it out. And as I said, you know, it looks like it's brightening. Um, so don't know anything yet. I've made this stack. I'm going to go back and look at the individual images. As I said, I've got 180 of them, and I will do photometry on um, probably at least a couple of the brighter stars here. Um, zoom out. Yeah, so I'll probably do photometry on this star and this star at least. Um, and then yeah, I'll just have to look at the brightness there and see what's going on. So that was an interesting exercise, and I'm glad I've got this data to work with. Um, yeah, this is actually a first. I don't think that I've ever imaged the motion of an asteroid before. So
Jim wants to know, if you invert that, what does it look like?
oh, I don't know. Let's see. Can I? Um, let's see. I've got it. Do I? Oh, yeah. I, let's see. What would I have to do? Uh-oh, this thing is. Oh, okay. I thought it was frozen. How can I easily invert this? I think I've got it. I think I've got it here. I could load it up in GIMP and go from there. Come on. Taking its time. I think this is it. Come on, GIMP. Yeah, there it is. So we can invert it. There you go. Oh, didn't want to do that. Okay. We'll just leave it as is. There's probably not much I can do with the brightness and contrast. I could do a little bit. So you can see these little tails here. That's the that is one of the limitations of this particular camera. That's actually caused by the shutter on the front of the camera. It does a little bit of diffraction, right? There's a little bit of diffraction as the edge of the shutter passes in front of the star as it closes. And so, yeah, you get these little tails. They're extremely low level, right? Extremely low level. But they are definitely there, and every star actually has them. It's just the brighter ones that are obvious, but all of them have it. But it's really low level. I haven't really looked at that yet. Anyway, so there's a pretty serious stretch there of that stack. So here's a hot pixel that didn't get dealt with. Maybe here's another one. Yeah.
So
anyway,
when it's processed, does the hot pixels go away or no?
Well, they would if I told it to. I just haven't told it to yet. So it's seeing, I think it's seeing, these faintest guys here, right? These really faint ones, which I mean, I wouldn't be able to measure, right? Not really. These are about 17th magnitude or so. These guys. I forget exactly what the brightest one is. I want to say it's probably maybe 8.5 or 9. Yeah. The asteroid itself, at least according to the information that I have, it was, I think, magnitude 10.6 or 10.8. I forget, somewhere around there. The high 10s. So you can see that
how many frames are in this image?
So this is about 180 stacked images. And that's why we see the motion of the asteroid here, right? Because it's, the stars, I mean, while they are technically moving, their motions are extremely small because they're so far away, right? So, the stars don't move, but an asteroid definitely does and will. I'm gonna have to look and see this over here. I think is probably a binary star, but it looks to me like a streak, right? So I'll have to investigate that a little bit. So yeah, not too bad. And yeah, it's always useful to look at these kinds of images from many points of view. Uh, yes,
And I'd like to thank you, Jim, for letting me know about using the if you use the dart frames, they should be able to do it on the spot.
yeah, yeah, and that's actually something that I moved on to R Leo, and I'm noticing that my for some reason I'm seeing artifacts from my darks in my stack. So, and I think I'm seeing it here too, because yeah, that shouldn't. I don't think that should be there. So, yeah, I've got to look at how I am doing that. Um, I mean, I've done it the same way forever. Um, so yeah,
Is it
yeah.
because of the camera or by the telescope?
What's that, Bobby?
And was it done by the telescope or was it done by the camera?
What?
Hey, here's a thing that will try me out tomorrow morning.
Alright. Alright. Now you were saying Cosmic and then I gotta go back again. I gotta get
All right. Well, you take care. You take care of things. I will hold the fort
no,
down.
no, 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 no. Yeah, so you were saying again and then I gotta like get to the freeze in the shed and get some ground meat.
Okay. No, I was just asking you what you said.
Yeah, I forgot. I'll be right back.
Okay.
I forgot.
Very, very good. Bobby's having some extracurricular activities today. So yeah, I don't know if it's not a straight line or not, right? It's kind of hard to tell, right? Don't exactly know. So there's sort of the raw unstretched image. Yeah. So that's why I say, Jim, my first thought when I saw that was it's like, oh, my code isn't stacking exactly right, because yeah, that should be. I think that should be a little straighter than what that is. So that's wandering around a little too much, and as far as I know, right, and I can be pretty sure about this, asteroids move in pretty straight lines, right? They don't wiggle around, not like this, at least. I'm pretty sure about that. So yeah, don't exactly know why it's doing that. Also, don't know why it looks like it's getting brighter and brighter until it peaks and then it starts to fall off again. So don't know if that's real or if that's an artifact of my stacking. Don't know exactly, but it's fun stuff and I like it. And yeah, it's something that I've never done, and definitely have an interesting set of data now to work with. I also have Asteroid Palace, which I haven't. I've yet to look at. So I think Bobby is back.
Yeah, on the question. Now the question I was asking was it caused by the scope, or was it caused by the camera? Those artifacts.
So what is it though? So what was caused by the scope or the camera? The what?
The artifacts.
Oh yeah, as I said, my guess is that it's actually my stacking software that just isn't quite stacking exactly right. So I'm going to have to look at that and see what's going on. Now, the thing that I can't account for is why it looks like it's getting brighter and brighter, and then it falls off again, right? So, yeah, I'm just going to have to look at all these things and see. So this will keep me busy for a little while, for sure. And as I said, I've got Palace to look at as well. So it was a pretty successful night.
Yeah, you did just have a good night on that one.
Yeah, yeah. Got lots and lots of data. But yeah, you know, the ultimate goal here, in case, in this particular case, is being able to measure the position of the asteroid over time, and also measuring the brightness over time, and then comparing those to, you know, the position. I can go to the JPL Horizons ephemeris generator and get the calculated position for where Eros was at that moment that I snapped the picture, and see how close it comes, right? See how close my positional measurement comes to the calculated one, to the model one. Should be pretty close, I would think. Don't know. We will find out. We will find out. But I'll be able to use all these stars as references, right? You know, because all these stars are in known positions in the sky. So I'll be able to use these stars to get a plate solution, as they call it, which will allow me to convert XY coordinates into right ascension and declination.
Now, the stacking software that you're using, is it like your own stacking software, or is it somebody else's?
It is my own. I wrote it all by myself. Yes, sir. So,
so you might want to be doing some debugging if that's so, right?
Yeah. I'm going to look and see exactly what the code is doing when it's doing this kind of stacking. See, because my code has to do two things, right? The first thing that it has to do is it has to shift images around, right? Like according to a reference image, right? So what I usually do is I just use the first image in the series as my reference, right? And I say, okay, in every single image that follows this one, there's going to be a pattern of stars, right? And in this case, I use this star and this star and this star. So these three stars right here I used. And I said, okay, this is the pattern, right? So in each image, I want you to look for that pattern and not only shift the images around, but I have to rotate as well because I'm on a altitude azimuth mount, and depending on where I'm looking in the sky, there's going to be field rotation. So as the telescope tracks the sky, there's going to be field rotation inside of these images. So I have to shift and rotate, and then I stack. And those two things are you know, complicated. So I'm going to go look and see. You know, this is the first kind of data like this I've ever had. Um, so you know, up until now, I've just stacked, you know, star fields, right? And you know, the stars look pretty round. You know, they're not. I don't think they're perfect, but they're definitely not, you know, streaks or, you know, really, really.
I'm not sure, Jim, if Deep Sky Stacker is made for Linux and stuff, but I'm not sure. But if you can make it, if it's not for Linux, but you can make it work with wine, you might be able to do something about it.
Yeah, yeah, and you know, I am definitely not against using other tools. I would actually like to see how these other tools stack up to mine. And you know, using other tools, I usually learn a lot, right? Um, so yeah, that's
Check our Instro's comment. Did you check our Instro's comment?
I was looking at that. Uh, yeah, no,
Yeah, it
you
was
know,
one to yeah.
yeah, you know, I'm telling the code, right, to look for this pattern of stars in every image, right? So it doesn't matter where this pattern is. If it's there, my code will find it, and then it'll just shift that entire image to the reference image. You know, so um, it'll put these stars right in the right place through shifting and rotating. But there are subpixel things going on here. And that's sort of what I'm seeing here, right? Is sort of subpixel wiggling around. So I'll figure it out. And as I said, you know, maybe it is just scintillation. You know, it's just that's just how it's going to appear. Don't know. But I like it. All right. Let's see. So it is 2:43 UTC. So we're doing good on time. So cheers. It's getting warm here in southeastern Arizona, in the southwest of the United States. It's getting warm. Starting to get a little warm. I think this time of year, we're likely to get maybe one more cold spell. Maybe one. Maybe.
Right here too.
What's that?
Yeah, maybe right here too. We might get at least one more stab before Easter comes.
Yeah. We've had snow here on
Welcome, Andy.
On May 5th. One year. So you know, anything is possible. Hey there, Andy. Nice to see you in the chat once again.
Welcome, Andy.
Yeah, excellent. All right, well, cool. You know, I was looking at archive.org before we got on. And I found a couple of kind of interesting articles right away from yesterday's listing. Today's hadn't come out yet. I was looking at yesterday's, and almost right away, I saw at least a couple that looked pretty interesting. I posted them over on the over on the Discord. But let's just continue looking at this list, and then if there's anything else that sort of pops out, looks kind of interesting, we can dive into it here for a little while. So let's see. I'm going to share my screen again. I'm going to hide that. Come over here, and we're just going to continue. I was on the 28th entry of yesterday's list. So let's see. Stellar angular momentum loss, scratches from the past, inflationary archaeology through features in the power spectrum of primordial fluctuations. That's a mouthful. Dust properties of multi-tailed active asteroid 6478 Gault. Oh yeah, I've heard about this guy. Yeah, so-called active asteroid. Pretty cool. Determining the depth of Jupiter's great red spot with Juno, a Slepian approach. Slepian? I don't know what Slepian means. Has been observed for more than 2 centuries, yet little is known about its structure and dynamics below its obscured cloud level. While its anticyclonic vortex appearance suggests that it might be a shallow weather layer feature, the very long time span for which it was observed implies it is likely deeply rooted. Okay. They probably have some, maybe, yeah, I don't know if you would necessarily use imaging for something like that, or if you would, using the microwave radiometer. Okay. So it is measuring light, just sort of in a particular way. So that suggested that the Great Red Spot is at least a couple hundred kilometers deep. I see. So they're doing some kind of gravity measurements. Cool. To determine the depth of the Great Red Spot based on the new gravity measurements and a Slepian function approach that enables an effective representation of the wind-induced, spatially confined gravity signal. 300 kilometers deep. Wow. Let's see, RDM stars. I don't know what an RDM. Radio flows of dark matter stars. Okay. These astronomers have these just wild imaginations sometimes. Search for the 835 hertz starburst oscillation signal in the regular thermonuclear bursts of, don't know if that's a star or a galaxy. Burst oscillations are brightness asymmetries that develop in the burning ocean during thermonuclear bursts.
This professional noob in the chat.
What's that? Oh, haha.
Just gotta get rid of an asshole.
Good, excellent. The system is
gotta get rid of a perp.
I want to see. Gotta see though. Okay, cool. That's like I say every single time, the the fact that there's a little bit of noticeability means that there's a little bit of recognition, and that's nice. Word is spreading. Anyway, so yeah, I don't know what 4U 1636 minus 536 is. It looks like maybe it's a star.
There we go.
So that's a pretty high frequency for a burst. Wow. Pretty interesting that they're seeing those kinds of oscillations at that frequency. That's, wow, that's pretty fast. Interesting. Let's see. Flux tubes. Going to be hearing more and more about flux tubes, I think. Interstellar dust grains. Optical spectroscopic observations of gamma ray blazar candidates. Nice. It's always nice to see, you know, reports of observations and stuff. Quite a few, over 3,000 of them. Wow. Massive amount of work. Just insane. That's just crazy. Look at all the, what, 4 different telescopes there? Wow, just amazing. Reverberation mapping project. Wow. Ground-based radio velocity. Future NASA Earth-finding missions. QED is negligible for neutron star spin down. QED is quantum electrodynamics. It's what all astronomers are taught, QED. Let's see. A simplified general relativistic model to analyze the structure of spiral galaxies. Wow. Still don't know how those things work exactly. Still trying to figure it out. Fluorine abundances. Fluorine in globular cluster M4. Now, M4 is a beautiful globular cluster in the constellation of Scorpius. It's right next to Antares, just like right next to it, and it's a big, beautiful cluster. And actually, right next door to M4 is M80, which is also a globular cluster. So both of those are Messier objects. Both of them are globulars, but they are measuring the abundance of carbon, sodium, and fluorine in 15 red giant stars in M4. Oh, and also 6 red giants in Omega Centauri, which is another absolutely fantastic globular cluster. Not a Messier object because it's too far south. So Charles Messier never saw Omega Centauri, at least not when he was making his list. I'm fortunate here. I can actually see Omega Centauri.
Our Astro is saying M80 will make the globular cluster of your hand if you're not careful.
Very, very true. Very, very true. All right. So anyway, so yeah, they're looking at M4 and Omega Centauri. Like I said, I can see Omega Centauri from my location. It's got to be, you know, the right kind of year. and they're sort of in the same part of the sky. So Omega Centauri is south and west of M4. But the globulars, they like to hang around the center of the galaxy, so they're sort of arranged that way. But yeah, that's pretty amazing. They're seeing fluorine and sodium and carbon. It's pretty amazing. Let's see if we can just grab a spectrum here. It's got to be a spectrum. Let's see. Oh, that's the temperatures. The NOAO Phoenix spectrograph on some big scopes, 8.1 meter Gemini South. Yeah. Also in the shell spectrum, this is a very, very high resolution spectrograph. Abundance analysis. Let's just look for some
So, on Astro,
spectra.
I say one of the things I like about my repeated missions to the Caribbean and Central American was the sight of the S Cross and Centaurus constellation. And Jim is saying we are made of stardust.
Yes, sir. Yeah, our Instro, given the opportunity, I will definitely go to the south to look at the southern sky. I don't think that's ever going to happen, but yeah, that's okay. I'm pretty happy with what I've got. But given the chance, oh yeah, absolutely. I'm not going to be able to recognize anything. So this is a really long paper. Looks like all the pictures are at the end. Tables. Okay, so here's all their observations, right? Line lists. Oh, we didn't look and see what wavelengths, but if there are plots, they'll show us.
Hey there, Chuck Daglum, what's up?
Hey there, Chuck. All right, there's some spectra. So it sort of looks like, oh yeah, okay, so they're looking in the infrared, right? So 23,000 angstroms is I think that's 2.3 microns. I think so. Yeah. So this is definitely in the infrared. Lots of interesting things going on here, I guess. Sodium. Is that hydrofluorine? Is that what they're saying is fluorine? And there's some kind of carbon. Oh, I guess that's just carbon monoxide, right? So
Okay,
lots.
so our Astro is say Scorpion, Orion, depending on the season, can get really high in the sky, at least for this North American's perspective. Makes me realize just how big a constellation Scorpio really is.
Yeah, it is. It is for sure. All right, well, cool. I'm definitely not, very good at reading spectra, but I'm not quite sure why they don't identify all the lines here. They seem to be, identifying the ones that they want to, but that's about it. Let's see. Okay, so yeah, so now they're just getting into line profiles, right? So the shapes of these lines, can tell us all kinds of interesting things about, the abundance of whatever molecule we're looking at, and then that molecule's environment, right? How hot it is, maybe how dense it is, how it's moving. So spectra are pretty amazing things. And I'm not going to try too hard to get into this too much here. Lots of red,
Our
green, and
intro
blue.
is also saying those lines seem awfully regular. Perhaps they're just artifacts or multiples or something like that.
Yeah, they're they're obviously features that aren't of any interest to the researchers. It's sort of like Messier making his list, right? It's like these are things that we're just not interested in. Okay, there's the end. So, okay, well, pretty cool. It looks like what they were doing here was trying to see if they could identify fluorine, and yeah, I mean, this sort of indicates that it's there. I guess these are different different detectors, right? And so Phoenix saw something at the right wavelength. This one, well, I don't know. This one, yeah, there's something there. But our ROA, is that ROA 324? Okay, yeah, they're not even showing all the spectra. So I don't know. Pretty interesting, though, that they're finding, well, at least they think they're finding fluorine in these stars. The Virgo overdensity explained. Denuded dwarfs demystified. Dispersion, statistical detection of clumps, time evolution of broadband non-thermal emission from supernova remnants. The supernova regulated interstellar medium. Number 6, magnetic effects. So yeah, a lot of times, these series are published, and if you want to get into it, man, this is the place to do it. Titan atmospheric aerosols. Spatial resolved outflows in Seaford Galaxy. Wow, lots of new things yesterday. Constraining observational study of hydrocarbons in the bright photodissociation region of Messier 8. Messier 8 is the Lagoon Nebula down in Sagittarius. A very beautiful nebula. They're looking for hydrocarbons. Wow, pretty amazing. Oh, I accidentally clicked on that author. There we go. Okay. Galaxy spectrum and star formation. No, there's always ways to recover. Okay, so radio detection of neutron-induced air showers. Cool. Okay, well, let's see. There were a couple here. Oh yeah, it was about well, there was this one talking about observing exoplanets from a balloon platform, which I thought was kind of interesting. But there's, I guess, I don't know why, but I'm always intrigued by new astronomical projects, and this one is called Twinkle, and it's a well, here, let's just take a quick look here. So Twinkle is an upcoming 0.45 meter space-based telescope equipped with a visible and two near-infrared spectrometers from the spectral range 0.4 to 4.5 microns. So that's a pretty wide range. I mean, 0.4 is almost ultraviolet, and 4.5 microns is way into the infrared. It's almost into the thermal infrared, with a resolving power of 250. So this is just exploring the capabilities for small bodies science.
Yeah, don't get me wrong, Jim. I thought it was YouTube that pretty much got choked earlier today while I was looking at a special presentation that the Harvard Fairbanks is doing, but found out that my router crashed.
Okay, so interesting. So they find that that over the course of a decade, several thousand asteroids enter Twinkle's field of regard, they call it, with a brightness and non-sidereal rate, which would allow Twinkle to characterize them. Cool. Hundreds of comets. So, okay. Is it like these guys are just going to be pointing at the same place for 10 years? Compositional characterization of small bodies provides a means to identify products of the solar nebula during the epochs of planetary formation. Okay, yeah. I want to see 2.4 meter diameter. James Webb. Twinkle Space Mission is a new fast-track satellite designed for launch in 2022. It's been conceived for providing faster access to spectroscopic data from exoplanet atmospheres and solar system bodies, but it's also capable of providing spectra of bright brown dwarfs and stars.
You have a good night there, Jim.
Yep. Take care, Jim. Thanks for coming in. Managed by Blue Skies Space Limited. So scientists will be able to purchase telescope time. See, I'm telling you, there's a business model here that might just work. On-demand observations. So a telescope, 0.45 meters. That's pretty darn big, right? That's pretty big. So no imager, right? It's not going to be taking images. It's going to be taking spectra. So that's cool. Spectrometer is detailed in there. Split, the platform has a pointing accuracy of 1 arc minute. Therefore, a fine guidance sensor camera is to be used, right? Low Earth orbit, 600 to 700 kilometers, sun synchronous. That's a smart move. Let's see, the bore side of the telescope, twinkle spectrometers can cover similar wavelength. Fine, yeah. So you can buy time to look at other things, but I guess their main thing is going to be Twinkle's field of regard provides restrictions on the targets which can be observed. Let's see. Guess I'm trying to understand if this thing is going to be pointing all over the place, or if it's just going to be looking in one place. The capability to observe small bodies is determined by calculating the sensitivity and saturation limits of Twinkle's instrumentation for each spectrometer. All right, well, I would definitely have to get into this a little bit more to really, I guess, be able to be able to answer that question. So it's, I mean, we need more telescopes in space. That would I think alleviate a lot of the having to wait for telescope time with HST. That's just I mean, that's going to take forever, right? So let's just put up a bunch of telescopes up there, and either sell or lease the time, whatever it is. And a lot of things can be done that way. I think we should. All right, well, I'm looking at the time, and I'm noticing that it's about 12 minutes after 3 UTC. So, yeah, I think it's about time to get on out of here for today. I'm pretty worn out. It was a lazy day, but it's nice to have a lazy day and just be pretty satisfied at the end of the day that we're done. We're done. So, all right, everybody, take care. Cheers and all that. Have a great evening, a great day. Live long and prosper. Make sure to smash the thumbs up if you so desire. Make some comments. Spread the word. Yeah, this is all about astronomy. All right. Take care, everybody. I will see you on the spin. See you later. Bye.